Hi everyone, we are Sergio Muñoz and Santiago Jiménez, and today we are going to explain you about two different types of diodes, which are photodiodes and laser diodes. So let's into it.
So let's see how a photodiode works. A photodiode are a class of diodes that convert light to electricity. These diodes are used to detect the brightness of the light that shine on them. So let's start with a PN junction. We have the P side and the N side. So to make it detect the brightness of the light, you have to reverse bias it. So the negative of the battery have to be with the P side, and the positive side of the battery has to be with the N side of the PN junction. Before we shine light on it, we should know that a PN junction contains holes on the P side and electrodes on the N side. Between them, the depletion region. Before we shine light on it, we should know that a PN junction contains holes on the P side and electrons on the N side, and between them, the depletion region that acts like a barrier for the holes and the electrons to don't make it diffuse into each other. So as we have a reverse bias, the holes of the P side are attracted to the negative of the battery, and the electrons are attracted to the positive of the barrier. And this makes that the depletion region be more bigger and larger. That is what we want. When we shine light over here and the photons have enough amount of energy, the electrons of this part can absorb part of that energy and jump. As a result, notice that we will have a free electron and a free hole. The electron is gonna be attracted to this side and rejected of these negative charges, making that the electron accelerate to this direction. Similarly to the hole is gonna be rejected from this side and attracted to this negative charge, making the hole going to this side, producing a current to the left. With more amount of photons and energy will produce more amount of electrons and holes, making with more brightness of the light more current. The voltage versus the current in a photodiode look like this. This is the voltage and this is the current. In forward bias, we have a normal diode. In this way, we have this magnitude of current. So the current is not going to depend of the voltage in certain point, because as we saw, it will depend of the light. It depends just a little bit because the voltage get more negative, the depletion region is gonna be larger, and it is going to be easier to get free electrons and holes. But in certain point, the depletion region is not going to be too much larger. So this magnitude depends only the light. Between more light, there is gonna be a higher current. So
now that we know what is a photodiode and how it works, it's important to make a question. Why use this kind of diodes? Why use photodiodes? So the photodiodes are unique among light detectors in that when they are illuminated, they generate an output which is proportional to the light level. So like Sergio explained just a moment. So their characteristical features can be summarized as follow. So it's important to point a few things about the benefits of use photodiodes, like the low cost of this, and the near IR photodetector. Excellent linearity in output photocurrent over 7 to 9 decades of light intensity. A fast response is an important point. Fast response. And also it is important to say that this kind of diodes make low noise. Also, these kind of diodes are useful with almost any visible or near infrared light source, such are LEDs, like the neon lights, the fluorescent lights, incandescent lights, or bots, the laser flame sources, sunlight, and we can continue furthermore. Here are a few examples of where photodiodes have been used. So we have three important industries where we can find it. So the first is in the cameras, in which they use to make the autofocus, and the medical sector, where they use this kind of diodes to the blood particle analysis, and in safety equipment, where they use it as smoke detectors and flame monitors. So now we review what is about, or what is a diode in general terms, and what is a photodiode. Now we are going to explain and show you what is a laser diode. So basically a laser diode is very similar to what we know like LED. So it's basically a diode that can emit a light. So to start, well, this is the symbol of a laser diode, and it works in 3 steps, which are light absorption, spontaneous emission, and the last one is going to be simulate emission. So what are these? Basically, light absorption is when we have external sources like DC source, or for example, in which the P and N junction. With these three steps, now we see the P and N junction, where thanks for the DC source or any source, here is going to be movement with the electrons and holes. Where thanks for a given more energy from the source, this movement is going to be every time higher or more significant. So it's important to say that here we work like a normal diode with the normal polarization with the DC source, and here is going to be a unique characteristic from the other diodes, in which in this part we're going to have like a interzone in which the free photons, which are going to be created from the movement in the P and N junction, is going to make the photons bounce in this zone over and over again. This part of how this diode works is the emission, and for the last one is going to be where in this section there are going to be a lot of photons. At when this level of photons reach a certain point, they're going to be free, or going to be like they're going to be free, like a light in this direction. So to make this laser diode as we know, like a laser, we need a length which is going to be right here, which can provide us to see a direct light from the laser. In this point, we need to explain what types of light emissions are. So we have the light of the sun, for example, which is something like that, and the light of a bulb, like in any house, is going to be something like that. And the last one is going to be the emission of a laser, which have a very specific graphic, in which is going to be the same over and over again with the same frequency, and that's why we can focus this kind of light with a lens and see a straight light from a laser, for example.
Some applications of the laser diode are the CD and DVD readers, the barcode scanners, medical applications to surgery in the eye or the brain, remote control applications, detection systems like the typical laser that we cannot touch in the movies, range finders, and communication systems. Thanks for watching us. We hope you like the video. Share with your friends the video, and we will see you in the next video. Bye.